All right, and here we have another HMMT question. Sorry about that. We're asked to find how many times 24 divides into 100 factorial. So this is from the HMMT. I don't know which year, but it's not very recent, so it's a little old. Okay, how do we do this? Well, this is something that's incredibly common. Maybe it wasn't as common when it happened back then, but this is not niche. It comes up on lots of AMC types of questions, maybe math counts, all the other sorts of competitions as well. And there's one very nice strategy to know for this. So if you're given 100 factorial, right, or if you're given n factorial in general, right, you can generalize everything I say here. If you're asked to find how many multiples of 3 you have, you would just do 100 and then divide that by 3, and then you take the mod of that. And then you would add this to whatever you get over here, divided by 3, not mod, so I don't know why I said that, the floor of that. Then you do the same thing again and again. So now you get 33 mod, floor 3, or 33 over 3, and then like this. Right? And you keep going until you're done, until you start adding zeros, essentially. Right? Now, this is all well and good. Of course, we can't really do the same thing for 24. And the reason for this is that 100 factorial is like 1 times 2 times, believe me, I'm not writing out the whole thing, but I'm just leaving it like this for you, times 24. And if you just do the same thing blindly with 24, you'll find, hey, 100 divided by 24 is like roughly 4. It's a little bit more than 4. Not greater than or equal to, it's strictly greater than 4. And it's less than 5. So we can say that it's going to be 4 plus 4 over 24, which is 0, so it's just going to be 4. And there, we're done. Except that will give you 0, right? That's completely wrong because, and that's why I wrote so many terms here, when you're multiplying these, doesn't the 4 and the 6 over here already give you a multiple of 24? And then when you add in the 12, the 2 and the 12 will give you yet another multiple of 24. And then when you add in the 8, then the 3 and the 8 will give you another multiple. So this is a very naive approach. Do not do this for non-primes, right? Because any composite number will have primes composing it. You should do it on those primes instead. So not do this for composites. What do we do though? Right? Like, I mean, there should still be some approach. We're not going to actually sit there and compute how many possible things come up, but we can take inspiration from what we did over here. First of all, 24 is not too complicated. It's 2 cubed times 3. And so to have a multiple of 24, you need some 2 times 2 times 2 times 3. Where you get these 2's is really not of consequence as long as you find them in the 100 factorial. And so in total, we just need 3 times as many factors of 2 as we do 3. And then, so if we have n 3's, we'll need 3n factors of 2 to give us 24 to the n. Right? 24 to the n would be equal to 2 to the 3n times 3 to the n. And so, yeah, I mean, you need either whichever one of these is less will kind of give you the value that you take. Okay, if that's a little confusing, you'll see what I mean. So now let's see how many factors of 2 there are in 100 factorial, right? So you'd have 100 divided by 2, that's 50. Then you'd have 25. Then you'd have 12.5, which becomes 12. Then you'd have 6. Then you'd have 3. Then you'd have 1. Adding these up, what do you get? Okay, looks to be about 75 plus 18, 22. Is that right? 22. So that is, I think, 97. Okay. And this is with 2. Now, what about the same thing with 3? Pause the video and try this on your own. Shouldn't be super hard. It's basically the exact same process. And you'll see that we end up with 3 and then 1. And do the math over here, please. It's not bad. It's like 44, 48. All right, now we've got 48 and 96. So if you have 2 to the 97, not 96, times 3 to the 48, this is equal to, be very careful here, right? Because you might be tempted to say, oh, well, 48 is less than 97, so this will just be 24 to the 48. But remember, this would require you to have 2 to the 3 times 48, which is obviously not met by this. So instead, we have to actually divide 97 by 3, right? We want 2 cubed to the, what is that? That's a 32nd, times 2 times 3 to the 32nd times 3 to the 16. I'm writing it all out like this. Never do this on an exam because you don't have all day to take the exam. And then you could write this as 24 to the 32nd times 2 times 3 to the 16. And you can see clearly that you're not going to get another multiple of 24, a factor of 24 in there. And so, yeah, this and this will give you your desired thing. And the answer is, of course, just 32. And just like that, you have solved question 3 in about 2 minutes. Okay, a little bit more than 2 minutes, granted. But yeah, very, very common strategy. Okay, I'm going to put it in a different pen just so you like just highlight this. Oh, wait. Okay, one sec. I'll put in a different pen just so you really remember. Very important. Very important. Okay, absolutely remember this, because imagine getting like a nice easy question like in the top first first 10 of an AMC 10 or 12 and not remembering the strategy, right? That would be 3 points lost. So you must know this at all costs. It's super easy to learn. Pause the video, ask any questions in the comments if you have them, but absolutely learn this. It's super quick and it's got very, very high rewards. Okay, so hopefully you understand it now. This is about as hard as the questions tend to get because you'll have to do a little manipulation like this, but hopefully this helps. Thank you so much for watching, and bye bye. See you in the next video.